Okay, this is an important formula that we'll be using a lot, so let's prove it here. Um, so we will let x equal x1, x2, dot, 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 all the way down to xn. And then the quantity on the left is equal to x1, x2, blah, blah, blah as a row vector. And then you have same vector, but as a column vector. Now we're doing matrix multiplication. This is 1 by n, and this is an n by 1. So the answer is going to be a 1 by 1 matrix, which we will write as just a real number. And what do you get? Well, you do first row times first column, and you get this sum of squares here. Now I'm trying to arrive here. Now the formula for the length has a square root in it. So what I'm going to do is put that in. And then on the outside, I will take it away by squaring. So what do you get? You get the length of x squared. Okay, so again, this formula, we're going to use that a lot. Okay, the distance between two vectors in Rn is, well, we're going to define it to be subtraction followed by taking length. Now, let's motivate this definition. Notice that u minus v, that's the same as u plus negative v. Or maybe we'll write it as negative v plus u. Okay, so you can imagine starting here at the tip of v, and you go negative v, and then you go plus u. So you end up here. Connect those points with a vector. That is the vector u minus v. Okay, so what I did there was I convinced myself that u minus v, in some sense, is the vector that goes from here to here. If you don't understand what I just did, I recommend you watch that part of the video over and over and over again, because that bit of reasoning is going to be important, very important later. Okay, so now we can see why taking the length of this vector gives me a reasonable quantity to assign to the distance between u and v. Okay, exercise, I want you to try to find the distance between these two vectors. So I just use this formula. And, well, these numbers are large, so don't forget that k times a vector vk can come out. Okay, so pause, copy, try. Okie dokie. U minus v, oops, is, that arrow is funky monkey, okay. is subtracting, I get 75, 125, and then negative 25. Yeah, so just for fun, let's factor out negative 25. And I'll get negative 3, negative 5, 1. So therefore, the length, which is u minus v, is absolute value of negative 25 times the length of this vector here. So 9, I square that, plus 25, plus 1, which is 25 square root 35. Yeah. I, J, and K. Okay. In chapters 1 through 4, we were calling these E1, E2, E3. So also known as E1, E2, and E3. So if you're in R2, I is equal to this vector, J is equal to this vector. So it's kind of an alternate notation instead of using E1, E2, and E3. Unfortunately, both notations are quite common, so we're going to have you learn both of them. And then in R3, you have K as a third vector here. Okay, so these vectors are what we call unit vectors. So copy this definition here. So a unit vector is unit referring to the number 1. Okay, so the length is 1. So if your length is 1, then you are a unit vector. Now, so pause and copy this example. So we're going to find the magnitude or length of this vector here. So what's going to happen is the length of this vector is going to turn out to be 1. So what this gives us is a way to scale a vector down, take a vector, scale it down to obtain a unit vector, which we'll find is useful in many cases. So to find the magnitude of this thing, I will just directly calculate. Because the idea here is that in my red bracket here, that's a K, that's a number that can move out front. I'm not going to put an absolute value on it. Forgot my arrow. Because I know that that's certainly positive. Okay, it looks maybe funny, but what I did is I took this and just moved it out front. So what do you get? Length of x divided by length of x, which is 1. So when I take x and and I replace it with this scaled down version. We call that normalizing. Or you can just say normalization. Okay, so we'll do that in NYC. And when you take linear 2, you'll do lots of normalization. Okay, so let's try an exercise here. Normalize this vector here. So I want you to find 1 over the length of v times v. So pause, copy, try. First thing I'll do is find the length of v. Well, I'm going to factor out the 17, right? Otherwise, I'll be in trouble. I don't like being in trouble. If you find yourself confronted with big numbers in this class, then you are doing something wrong. So where are we? We get 17 times 3, which is 30 plus 21, 51 units exactly. Therefore, the answer I want here is 1 over 51 times the original vector v. And it's usually best to leave this out front.